Okay, so now that we've seen or covered the topic of logarithms, and we've seen the properties of logarithms, now let's work on some problems from homework task 8. And so you guys are going to be working on the odd problems. So I'm going to be solving some of the even problems. So these are going to be from section 3. So in these problems, we have to find the domain of the function. We've had to find the x-intercept and the vertical asymptote of the graph. And we also have to do the graph of the function, okay? So let's get to it. Let's see how we can do that. So let's look at problem 26, okay? So problem 26 says that f of x equals minus logarithm base 2 of, let's see here, x plus 1. Let me draw that. So let's start off with the first part, the domain. Okay, so this is not that complicated. What is the domain of this function? Well, remember that when we were talking about domains previously, we talked about restrictions. So in the case of a function that had a quotient, the denominator can't be 0, right? In the case of a function that has an even root, whatever's inside the even root cannot be negative. Well, here, this is something very, very important. There's another restriction that we're going to add with logarithms. So in the case of the logarithm, if we remember the domain of the logarithm, the domain of the logarithm was, because it's a one-to-one function and it's the inverse of the exponential, the domain of a logarithm function was numbers from 0 to infinite. So in the case of a logarithmic function, it has the same restriction as an even root. What does that mean? This value that's inside the logarithm cannot be less than 0, or rather, it has to be larger than 0. Okay, that's going to be the restriction because that's the restriction of the domain. So x plus 1, or rather, it has to be positive. X plus 1 has to be larger than 0. And so this means that the domain is x larger than minus 1, or from minus 1 to infinite. Okay, that would be the domain of the function. Okay. Now, the other thing that they're asking us to do is to find the x and the y intercept. So let's start with the y-intercept. The y-intercept is going to occur for f of 0, meaning that the x has to be 0. And so f of 0 is going to occur when we make x equal 0. So f of 0 is going to be equal to minus logarithm base 2 of 0 plus 1. And so this is going to be equal to f of 0 equals minus logarithm base 2 of 0 plus 1 is 1. Now, we've got some properties of logarithms that we should not forget. The logarithm of any base of 1 is always going to be 0. And again, that's one of the properties we saw. The logarithm of 1, regardless of the base, is always going to be 0. So this gives us that the y-intercept, or f of 0, is going to be equal to 0. Okay, so we found that. Now let's look at the x-intercept. So the x-intercept is going to occur for f of x equals 0. Okay. And so what's going to happen here now is that minus logarithm base 2 of x plus 1 is going to be equal to 0. Okay, so what can we do there to kind of manipulate there? Well, let's remember the relationship between the logarithm and the exponential. Okay, remember that these are inverse functions. So if I want to eliminate the logarithm because I want to find the value of x there, if I want to eliminate the logarithm, one way of doing this is that I can elevate everything to the same base. Okay. And so I can do this. I can elevate. First off, before I do that, by the way, I can eliminate this minus because I can send this minus to the other side and that is eliminated. So this is the same as saying, or I can send a logarithm to the other side. So this is the same as saying log. I'm actually going to do this a couple of ways. Log base 2 of x plus 1 equals 0. So one thing that I can do is that I can elevate everything to the power of 2. So I can say 2 log 2 of x plus 1 is equal to 2 elevated to the 0. So basically I'm elevating both sides of the equation to the power. And what's going to happen if I have log base, if I have 2 elevated to log of the same base, these are going to be eliminated. Okay. And I'm just going to be left with x plus 1. And I know that 2 to the 0 is equal to 1. So I'm going to be left here with a 1. And if I solve here for x, this is going to give me x equals 1 minus 1. And so the x-intercept is going to occur in x equals 0. Okay. And so this is interesting because this tells us something. This tells us that our graph is going to go across the origin because the intercept in x is 0, the intercept in y is also 0. I'm going to do this another way. This what I did here, and this is an alternate way of getting to the same value. If I take this and I bring it over here and remember things about the domain, if I want the logarithm of base b of the value of 1 is equal to 0. This is one of the properties that we've seen. okay? So this means that if this is true, this means that this part here, x plus 1, has to be equal to 1. It's the same equation that I had here. If this is true, then x is equal to 1 minus 1, and I got to exactly the same thing, which is x equals 0. Okay. Okay. So that finds most of what we were looking for. Now they're asking us to do the graph. And actually doing the graph isn't that complicated, by the way. It's actually the same procedures we've done before. Okay. So to do the graph, I'm going to erase these things that we've got here. And we just have to remember that we've got the domain and the x-intercepts and the intercepts in 0. So I'm going to erase all of this and just leave the original function here. And we're going to try to do the graph. And to do the graph, let's just remember, and we're going to do this exactly as we've done the previous graphing examples before. And the way we did those previous graphing examples, if you remember, is that first we looked at what we called the base function. Okay, so let's look at the base function, or how the base function would look for an exponential. Remember it because we already saw it. So the base function is this one that we've got here, the red one. This is the base function for a logarithm of base b. It's always going to cross in 1, 0. It goes from down upwards, and it's going to cross there. Okay, so let's take that and graph it as a base function, similar to what we've done previously. So the base function is going to look something like this. And remember, we always draw that one in blue. So the base function is going to look something like this. Okay, that's the base function, and it's going to cross in 1. So let's just remember a few of the things that we had been talking about previously when we looked at graphs. Okay. What is one of the first things that we see here, and this is, in this case, this is a logarithm base b. It's a logarithm base 2 in this case. It's going to be the same model of the graph. So let's do the graph here step by step. So if this is the base function, the first thing that we're seeing here is that we're going to have a negative. Okay, remember what happens when we do the negative? The graph is going to flip. And so now what we're going to have is that, I'm going to mark this here, we're going to have a negative here. Okay, this is the first part that we're going to look at, and this is a reflection. Okay. And so what's going to happen now is that the graph is going to be reflected in this case in the x-axis. So what we're going to have is, now we're going to have something like this. Okay. So that's that first part. It's going to be reflected. Next, what do we have over here? We're going to have, inside the function, we've got a +1 here. And remember what happens when we have plus something plus or minus something inside the function, that's going to be a shift. Okay, this is going to be a shift. And since it's inside a function and it's a +1, it is going to be a shift to the left. Okay, and so now what we're going to have here is that if I move the graph to the left 1 unit, always let's look at the references. What's going to happen with this 1? If I move it to the left, now the 1 is going to be here in the 0. So instead of crossing in 1, it's going to cross in 0. And originally I had an asymptote here in y equals 0. If I move it 1 unit to this side, now the asymptote is going to be here in -1. So basically what we're going to have now is that I'm going to mark the -1 here. And I'm going to mark it with a different color. We're going to mark an asymptote because remember that we've got the graph going through the graph is going to go through here 1, but the graph of a logarithmic function is always going to have an asymptote. And we're going to have over here the 0. And what we're going to have then with the shifted graph is that now the graph is going to go something like this. Okay. And remember what we talked about previously, the x and y intercepts. Remember those? The x-intercept was in x equals 0. And we also had the y-intercept. And the y-intercept occurred in f of 0, which was also going to be 0. And that is congruent with our graph because the graph is crossing here in 0, 0. So we've got an intercept here in 0, 0, which is congruent with what we had calculated. Okay, and so this would be the graph. And we're actually applying exactly the same things that we did previously when we were talking about graphing functions. This is a function, and we're seeing shifts, we're seeing reflections, etc. It's the same thing we were doing previously. Okay, so now let's do another one. Let's do 30. Okay, so for 30, we've got f of x equals 1 minus 2 logarithm base 4 of x minus 4. Okay, so let's do exactly the same thing we did before. First, the domain. Now, for the domain, let's remember that the only restriction we have is that whatever is inside the logarithm, which in this case is this, has to be larger than 0. Okay, so this means that x minus 4 has to be larger than 0. This means that x has to be larger than -4. That means that the domain goes from -4 to infinite. Okay. Same restriction as the even roots. Whatever is inside cannot be larger than, cannot be negative. And then let's look at the intercept. So the y-intercept is going to occur for f of 0. Okay, so what happens with f of 0? With f of 0, we're going to have 1 minus 2 logarithm base 4 of 0 minus 4. Okay, and this gives us that f of 0 equals 1 minus 2 logarithm base 4 of minus 4. Okay. And so we have to do those calculations. But before we move on, let's look at something here. We've got, let me just clear this up a little bit. We've got the minus 2 logarithm base 4 of minus 4. So what happens there? Can that be calculated? No, it cannot be calculated because we just said that it has to be larger than minus 4. It's a negative number, okay? It is a negative number inside a logarithm. So this cannot be calculated, okay? So what does that mean? There are no y-intercepts. That means that somehow this function is not crossing the y-axis, okay? So there are no y-intercepts. Now let's look at the x-intercepts. For the x-intercepts, we are finding f of x equals 0. Okay, so let's do that. So we've got 0 equals 1 minus 2 times the logarithm base 4 of x minus 4. And we'll start manipulating this here. So let's send this to the other side. And so we change that sign. And so we're going to have 2 logarithm base 4 of x minus 4 equals 1, and we can send this 2 to the other side dividing, and so we're going to have logarithm base 4 of x minus 4 equals 1/2. Okay. And so now what we're going to do, let's apply the base. In this case, we've got 4 as a base. So let's elevate everything to base 4. Okay. Just clean this up a little bit. And so this is what we have. So to eliminate the logarithm, I'm going to elevate everything to base 4. Okay. And so what happens here when I elevate everything to the base, this is going to be eliminated. And we're going to have this here. We're going to leave that there. We're going to see what that turns out. We're going to be able to do some calculations. So this is going to be the same as having x minus 4 equals 4 elevated to the 1/2. Okay. Let's assume that we don't have any calculators. And so if we don't have any calculators, how can we calculate this? Well, 4 elevated to the 1/2 using the properties of the exponentials, okay, is the same as having actually the square root of 4, because this is elevated to the 1/2 is the same as having the square root of 4, and the square root of 4 is equal to 2. Okay, and so we're going to have x minus 4 equals to 2, and this is going to give us x equals 2 plus 4. And lastly, this is going to give us that the x-intercept is going to be an x equals 6. Okay. And so now we found the x and the y intercepts. Last thing we need to do now is find the graph, or not find the graph. We need to do the graph of, or sketch the graph of this function. Okay. And to do that, I'm going to clear the drawings here. I'm just going to leave the original function. And we're going to do something very similar to what we did in the previous one. And so first we need to remember what our base function is. Okay, I'm going to draw that in a second. There we go, we're almost done. Manual erasing. Okay. So let's look at the base function. Let's remember the base function first. And so the base function is going to be according to, and again, remembering the base function is going to be like this, the red one here. This is the one that we're going to be drawing. So the base function is going to, remember that the base function always crosses in 1. And so the base function is going to be, oops, coming from 0, and it's going to cross in 1 like that. And let's do the same steps we've always done when we're doing graphs. Let's look at what's happening with the graph. And so let's look at this part here. First, we've got this negative here, and we've got a 2. So the negative is going, the 2 is going to generate a stretch. I'm going to do this since you guys already know this. There's 2 things here. There's a 2 and a minus. So this is going to be a stretch and a reflection. Okay, so remember that we're just doing the graph. So it's still going to cross in 1, but it's going to be reflected, and it's going to be stretched. And the thing about it being stretched, remember that it only gets closer to to the y-axis. So what's going to happen there is that we're going to have something like that. Okay. And then let's see what else we have here. We also have a, let's see what we've got here. We've got this -4 here. And this is inside the logarithm. So this is going to be a shift to the right because it's a -4. So what we're going to have now is that we're going to have, so if we had a 1 here and we shifted it to the right 4 units, what would happen there? If we shifted it to the right 4 units, so instead of crossing in 1, it would now be crossing in 1 plus 4 is 5. Okay. So now the end, the asymptote that was originally in 1, now the asymptote would be 1 unit before where it crosses. The asymptote would be in, so I'm actually going to do this just to exaggerate this a bit. So this comes over here. So the graph would be crossing in 5, and the asymptote is always 1 unit before, so the asymptote would be here in 4. This asymptote that we would have here in the y-axis, now it's going to be in 4. So what we're going to have here, I'm going to stretch this out a bit. We're going to have now 4 here, and we're going to have a 5. And so we're going to have an asymptote here in 4. And so what we're going to have now is that this is going to cross, this is going to come here like this, and it's going to cross in 5. Okay. And lastly, we've got a 1 here. And the 1 is going to be a shift. And since it's positive, it's going to be a shift up. And so that would be the next step. So let's keep the references here. We've got the 4, we've got the 5, and now we've got a 1 here. And so now the graph is going to cross. I'm actually going to use another color, by the way, because I don't want to use green here. I'm going to use another color. Let's do pink. Let's do pink. So this 1 here, this 1 here is going to be a stretch. It's going to be vertical. And so now it's going to be shifted up 1 unit. And we had the 5 here. So now it's going to cross in that point. And we're still going to have the asymptote in 4. The asymptote stays the same. But now we've shifted it up. Okay. Just use another marker there. And we've still got the asymptote going here. And so the place where it's going to cross now is going to be here. And so now the graph is going to go something like this. Use the same pink color, so it's going to be coming something like this. Mark it a little bit more. Okay. Oh, didn't like that. It's a little bit better. So now it's going to go like this. I don't like that little spike there. I need to release the mouse before I do that. It's going to go something like this. Okay, that's better. Sorry, that's my OCD. So that would be the graph. There's one thing left that we need to verify here. And remember that we just need to verify our intercepts. Remember that we had an x-intercept that occurred for x equals 6. So that's congruent. In our sketch, it's roughly going to be crossing here in 6. So that's congruent. So this coordinate would be 6, 0. And remember about the y-intercepts? What did we find about the y-intercepts? That we had no y-intercepts. And why is that? We've got an asymptote here. And remember that's never going to cross the asymptote. And so since it's never crossing the asymptote, it is never going to be crossing the, it's never going to be crossing the y-axis. So that's also congruent, okay? So with these steps, we've found the graph, okay? With these two examples, you should be okay to start doing some of the problems from section 3 of homework task 8.